Hi, welcome back to the Shikong Math Practicing Lab, Learning Through Practicing. And from the previous video, we tried to do our practice number 2 is to determine whether the sequence converges or diverges here. If the sequence converges, then find the limit of a convergent sequence. So what we did from the previous ones here, we total had 12 problems. And so from the video number 1, for the practice 2, the part 1, we did the first 6. So this video, we're going to finish the last 6. So if you do not finish all the problems right now, probably it's a good time to pause your video and finish the remaining 6 problems, and then resume the video, and so you can, check the answer to see whether your answers match my answers or not. Okay, so now I'm going to go to the whiteboard and we're going to start practicing our problems here. Okay. Okay, so let's start. So last time we stopped at the F. So right now, let's try to do part G here. The part G, the sequences here is n squared e to the negative n here, right? So that means the an is equal to n squared e to the negative n, or you can write this is n squared e to the nth power. So remember from the previous video, we said find the limits, right? So we find the limits for the an to see is this limit, going to certain numbers here. So this is n squared en. So if you let the n put the infinity here, you get the what? You have the infinity over what? You got infinity over infinity. So how do you do it? So we can do is, we can use, we learned before, is the L'Hopital's rules here, try to solve these problems here, right? So now in here we can say that by the L'Hopital's rule, we say when the limit x approach to infinity, the x squared e the x's here. So either by using the L'Hopital's rule, we'll say that you can take the derivative. So this is, we say the L'Hopital's rule. So what is the derivative of x squared? The derivative of x squared is 2x. Then what is the derivative of ex? It's still ex. So now if you substitute the x to the infinity, what you have, you still have infinity over infinities, right? So we still cannot determine. So I'm going to apply what? I'm going to apply the L'Hopital's rule one more time. So this will be the limit n approach to infinity. So what is the 2x here? When you take the derivative, will be 2, right? So what is the ex? You take the derivative, will be the ex. Then when your x, so that when the x approach to infinity, so the bottom will become infinity. So when the denominator become infinity, then the whole fraction will become what? Will become to zeros here, right? So then we can apply the here, it's the same thing. So this is the n approach to infinity. Then this is n squared en because of the L'Hopital's rule. So we say this is 0. So we know this is what? Convergence sequences, right? So this is a convergent sequence. And what is the number it converges to? Is converges to zeros here. Okay, so this one is a little bit different. So remember, right? So when you try to find the limits, so we have so many different ways. So this one here is you need to use L'Hopital's rule. Okay, so now the h here. The h we defined is an is equal to 1 plus 2n, 2 over n over the nth power. So for these ones here, if you let the n approach to infinity, So if you let n approach to infinity, you will see this is 1 to the infinity's power. Then we know this is, we cannot determine, this is not the determinant form. So let's take a look, how do we do it? So let's say here, let's change to a function first. So I would say y is equal to 1 plus 2x to the x powers. Right now, I'm trying to find the limit x approach to infinity. So we can take the natural log of both sides, right? So when you take a natural log, this is the exponents, so we can move to the front. So this will be x and the natural log of 1 plus 2 over x, right? Okay, so now the limit, let's take the limit x approach to infinity, the natural log of y will be equal to what? Limit x approach to infinity, this is the x, 1 plus, 1 plus here is the natural log of 1 plus 2x. So when you put the x into the infinity, so you will see this number going to be the infinity, and this number going to be 1. The natural log of 1 is kind of like going to the 0. So you have a term 0 times infinity. So I don't know what is 0 times infinity, right? So that's why one thing here I can do is I will say, okay, so in order to do that, if you remember when we learned in the L'Hopital's rule, we say, hey, if you have like 0 times infinity, so what you need to do, you need to flip one of them to the bottom. So make your expression equal to 0 over 0 or infinity over infinity. So what I'm going to do here, so this is the natural log 1 plus 2x, right? I'm going to flip this x. Okay, so the way I flip it, this is x, right? So I flip it, this is 1 over x, right? So it's just be like the x times natural log x here. Then you try to use the L'Hopital's rule. So you say, okay, now I can use the L'Hopital's rule. That means you take the derivative on the top and you take the derivative on the bottom here, right? Okay, so let's take a look. The natural log derivative will just be 1 over 2 over x. Then what? You need to chain rule inside, right? So the chain rule inside, this will give you 2, the x to the square. You just chain rule the 1 plus 2 over x. Then the 1 over x, so when you take the derivative, is 1 negative 1 over the x squares here. Now, if you do a little bit of algebra, so you flipped it, right? So you flip it, so this will be 1 plus 2 over x. Then this is negative 2, the x squared. Then you flip this one, so here's negative x squared over 1, right? So now what do you see here? So the x squared cancel, and the negative and negative become what? Negative and negative become zeros. Negative become positives, right? Then you simplify these terms here. This term, you simplify it will be x plus 2, right? So you flip it. So this will be just equal to the limit x approach to infinity. Then this will be what? This will be the, okay, so here you got a 2 here, right? So if you want, you can just put a 2. This is 1 plus 2 over x. Okay, so now when you see, you know, when the x approach to infinity, so what happened to these terms here? X become what? Pretty big. So this term approach to 0. So what is the whole thing approach to? The whole thing approach to 2, correct? And be careful here. And this one's here, take a look here. This is natural log of y, right? So I know the natural log of y approach to, you know, when the x approach to infinity is 2. So what is the y's here? Y is e to the 2. Okay, so I know this approach to a fixed number. So this sequence is what? This sequence of converging sequences, right? And what is the number it converges to? It's converged to e to the square. So it's a pretty neat problem here. Okay, so now let's take a look at, so this is another skill, right? It's kind of like the review what you learn in the, I think in the calculus 1, when you talk about the limits, right? Okay, so you can take the, the natural log of both sides and simplify it. Okay, let's take a look at I. The problem I have a special way to do it also. So this is n, and this is n plus 1 times n plus 3, right? Okay, so n plus 1 times what? N plus 3. Okay. So the first, if you want to find the limit, n approach to infinity, right? So if you plus the n equal to infinity an, so what happens here? This term going to approach to infinity, this term going to approach to infinities, right? So the infinity over infinities, I don't know what is infinity over infinity. So we need to do something about it. So let's try to change this a little bit. So here, this is an's, right? Okay, so this is n minus. So these two square roots, I'm going to combine it. So it will be the n plus 1 times n plus 3. So if you plus times this will be n squared plus how many? 4n plus what? Plus 3 here, right? So now, I don't know if you guys remember or not. So when we do the limits, we say if it's infinity minus infinity, you have square roots. So what is the technique we use? We multiply the what? We call this the conjugates, right? Okay, so let's see here. So this is n minus. So this is n squared plus 4n plus 3. So remember, we say we times the conjugates. So this is the conjugates. We use this skill when we learn the limits, right? Like in the earlier chapters here. So this is n plus square roots of the n squared plus 4n plus 3. So don't forget, this is a very important skill, right? You times the conjugates. So what is the conjugates? Conjugates is like, if here is minus, and then here is plus, right? Okay, now I can do it. So now here, if you combine, the bottom will be n plus n squared plus 4n plus 3, right? So what is the top? Top is n minus times n plus. So we know in the algebra, so what is the formula? We say a minus b times a plus b is what? Is a squared minus b squared, right? So we can use this formula. We say, hey, this is n minus times n plus. So will be the n squared minus b squared. B squared is the n squared plus 4n plus 3 square root square. So what happens here is n squared plus 4n plus what? Plus 3 here, correct? Okay, so now if you simplify it a little bit, so this is n plus n squared plus 4n plus 3. So it will give you negative 4n minus 3 here, all right? Now you take a look, you say, oh, here, how do I simplify more? And then you say, oh, here got the order n, and the n's here. So maybe I can divide by n both sides, like on the top and on the bottoms here. So let's see here. So if I divide, you times 1 over n, both on the denominator and the numerator. So if you times 1 over n, so the numerator will be negative 4 minus what? 3 over n here, correct? Then the denominator, you times 1 over n, the first term become 1, right? Then the second term, you need to bring this 1 over n inside the square roots, so become 1 over n squared. So the first term disappeared, will be 1. The second term, because you bring in the 1 over n, so it's 1 over n squared. So the second term is what? 1 over n. And the third term is what? 3 over what? N squared. Okay, now I can let the n approach to infinity. Let's see what is this number giving us. Okay, so this is 1 plus. Okay, so now you see here, when n go to infinity, this term approach to what? Approach to 0, right? Because the denominator get pretty big. This term approach to 0. This term approach to what? Approach to 0 here, right? So it turns out then the limit here will be -4. You still have 1 here, right? Don't forget you still have 1 here, right? So this one will be, so it turns out it will be 1 plus 1. So the answer is -2. So we know this sequence is a convergent sequence, right? So what number it converges to is converge to -2. So this is a pretty good problems that show you, the different, the techniques, kind of like the limits reviews here, right? Okay, now let's go to doing the remaining 3. Okay, so the number j's here. So this is the an is equal to natural log n square to the n. So here. So like in here, you set a limit n approach to infinity an. What you're going to have, you have infinity over infinity. So as soon as I have infinity over infinity, then I cannot, the determinant. So now let's take a look at what happens if I change it to a functions here, right? So the x approach to infinity. So this is x, this is natural log x squared. So I know this is going to be infinity over infinity. So every time we see that, what rules we use? L'Hopital's rules, right? So we say this is limit x approach to infinity. Now you take the derivative on the bottom is 1. You take a derivative on the top, so it's natural log. So you use the power rule, take the 2 out, natural log x. Then don't forget the chain rule inside, right? So it's 1 over x here. So you will have here, so limit x approach to infinity. So you will have x to natural log x. All right. So you put the infinity again. So what happened? You have infinity what? You still got the infinity over infinity. So what I need to do? I need to use L'Hopital's rule 1 more times, right? So now you take the derivative here is 1. Then you take a derivative here, this is 1 over what? X. Now, this one will become limit x approach to infinity, 2 of x. So when x approach to infinity, what is the value of here? Is 0, right? So that's why I can conclude when the limit n approach to infinity, an's here will approach to 0. So I know this is what? This is a convergent sequence, right? And what is the value it converges to? Converge to 0s here. Okay, now let's take a look at case here. K, this one is a very interesting sequence. They did not give us the general term. So this is 1 over 1. This is 1 over 3. This is 1 over 2. And this is 1 over 4. And this is 1 over 3. And this is 1 over 5. This is 1 over 4. And 1 over 6. And right? So if you see these ones here, you said, this one is a little bit like the sequence is not like a 1 and 1/3, and then increase to 1/2, then drop to 1/4, 1/3. So how do I do it? So what is my an terms, right? So in here, you have to know, then you let the limit n approach to 0, infinity, and then you will know whether it's have a number or not. So now in here, I'm going to color coding this for you so you can see here, right? So this one's here, all right? So if you take a look at these numbers here, right? So the one I'm going to circle, this is 1. Every other one. What did you see here? What? So what did you see here? So you see here, right? So this is the first term, right? It's 1/1, 1/2, 1/3, 1/4. So you know it's like a 1, 2, 3, 4, 5, but this is the first terms here. So how do I write the common term for my pink one? So if you think about it, so I can write this way. So I said my 2n minus 1 is equal to 1 over n here. If you don't believe, you can say when the n is equal to 1. N equal to 1, so 2 times 1 minus 1 is 1, right? So it's a1. That means a1 is equal to 1 over 1. N equal to 2. Okay, n equal to 2. 2 times 2 is equal to what? 4, right? So 4 minus 1 is 3. So a3 is equal to 1/2. Here is true, right? So I know this one is okay. Now, let's take a look. What is here? This is 1/3, 1/4, 1/5, 1/6. It also, it seems like it's like it's a continuous 3, 4, 5, 6. So now, but you know, this is the second term, fourth term, sixth term, eighth terms, right? So I'm going to write this one in general. This is 2n is equal to 1 over n plus 2. Right? So the 2n is equal to the 1 over n plus 2 here. So let's take a look. When the n equal to 1, let's see, is this match or not? When n equal to 1, so 1 times 2 is what? Is a2. a2 is equal to 1 over 1 plus 2, so it's 1/3. Ta-da! Right, so when n equal to 2, what is an's here? 2 times 2 is 4. 4 is equal to what? 1 over 3, 2 plus 2. So it's what? It's 4. Ha. So I know this one matches here. So in fact, this sequences here, right, is the combination of the two different sequences. So I will say, okay, now let's take a look. Are they going to the same place? So this is 2n minus 1. That means this is equal to limit n approach to infinity, 1 over n. Oh, I know the 1 over n, the n approach to infinity. What's that? 0. Very good. So limit n approach to infinity, a to 2n. So what is this one? This is n approach to infinity, 1 over n plus 2. So when n approach to infinity, the denominator becomes very big. So still is equal to 0. So even this sequence is the combination of two different sequences here, but they approach to the same things. So I know this sequence is a what? Is a convergent sequences, right? So what is the value they're going to converge into? Converge into zeros here. All right. So this one is a very interesting one. So so you need to kind of be able to identify the patterns here. Okay, so the last problem here, problem L here. So they give you another sequences here. So this is 0, 1, 0, 0, 1. Then 0, 0, 0, 0, 1. Then da, 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 da. So for these sequences here, right? And so as you see, you know, for the first ones here, right? So they have a 2, 1, 0, then they have a 2, 0, have a 3, 0, and then 1. So when this sequence go into the infinity, you don't know this sequence is going to the 0 or going to the 1s here because it's always a 0, 1, 0, 1, right? So you don't know. So what is this sequences here? This sequence is a divergent sequence because I don't know it will end, end with 0 and end with 1s, right? So it will end 0 or end with 1. So it's not going to a one fixed number. So this is what we talk about is a converging sequences, a divergent sequences here, right? So it's very interesting. So like the second half of this practice, basically, they covered a few things we learned before, right? How do we use Rojo-Petros rule? How do we times the conjugate? How do we take the natural log to find the limits? All are very good problems and kind of the review about what you learn in the limits. So that's good. And so don't forget, practice, 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 right? So the practice make you good at maths here. So I guess we finished this practice sheet. So the next one, we're going to see a sequence is increasing, decreasing, or whether the sequence have a bound or not. All right, so nice talk to you. So if, hope you'll be able to get all this problem correctly, and that will be pretty good. Okay, so now we'll talk to you later. Okay, don't forget the practice, practice, and practice, all right?